Welcome back to my channel. Thank you for joining me on another episode of Prime Math Zoom. This lesson, we will be focusing on subtracting like fractions. Do you know what like fractions are? Yes, like fractions are those fractions with the same denominator. And remember, the denominator is the number at the bottom that shows how many equal parts the whole is divided into. So let's dive right in. Fractions. A fraction is an equal part of a whole, like this pizza here. See those equal parts? Yes, and if we count them all, we will see that we have 8 equal parts, where one of the equal parts is called a 1/8. So here we have 8 1/8 parts in this pizza. Now, let us consider this real-life situation. Deshane bought a bun, like this spice bun here, and cut it into 5 equal slices. She then eats 2/5 slices. How many slices are left? Okay, so she ate 1 slice, 2 slices. So she ate 2/5 of the whole, and the whole was comprised of 5 slices. How many slices are left? Of course, we could go right ahead and count how many slices remaining. 1, 2, 3. So if we counted 3 slices remaining, we could say that from a whole of 5/5, 2/5 were taken from it to leave a fraction of 3/5. Now, let us look at this math sentence here. Can you pick up any shortcut or any easier way to solve it? Right. If you look at the numerator, which is the top number, it shows how many parts are being considered from the whole. If you look at the numerators, you realize that if you find the difference of the two numerators, it will give you the numerator in the answer. So here we could say 5 minus 2 equals 3. And the denominator remains the same because they are like fractions. Let's see if this rule here works for every like fraction when finding the difference. Here, Liam bought a jar with 12 candies. He put 7 candies into his bag to take to school. 1, 2, 3, 4, 5, 6, 7 candies, and Liam will be taking them to school. Now, this here is Liam's friend. While at school, he gave his friend 3 of the candies. 1, 2, 3 candies. And the question is, what fraction of candies is left in his bag? So we remember that Liam had 12 candies to begin with, and he brought from that 7 out of the 12 candies to school. And 7 out of 12 can be represented like this. Now, when he got to school, he gave his friend 3 candies out of the whole of 12 candies. So we're working with the same amount of candies because that is the whole. So 3 candies out of 12 candies. If he gave his friend 3 out of the 12 candies, it means we are subtracting. So we'll be subtracting 3/12 from the 7/12. Now, if we want to know how many candies are left in his bag or the fraction, we just need to go ahead and count these. 1, 2, 3, 4. So here, let's see if it will work here. If we subtract this or find a difference between the numerators, given that the denominators are the same, will we now get the answer? Okay, so we counted 4 candies here, And we're going to put the 4 candies over the 12, which represents the whole. And we will say that 4 12 candies are left in his bag. Now let us look at this, the shortcut. 3 from 7 will give us what? We had 7 things here, we took 3 from it, 4. So yes, that shortcut will work all the time with like fractions. Let's move on to another one. The school's parking lot can hold 10 cars. If 6/10 parking spots are taken, what fraction of the parking lot is empty? First, let us count the parking lots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so 10 parking lots. And our cars here will be parked in 6 of the parking spots. So there. Right, so 6 of our cars, let's check. 1, 2, 3, 4, 5, 6. 6 of our cars are parked in 6 of the 10 parking spots. 6/10 is the occupied parking spots. Now we need to find what fraction of the parking lot is empty. Of course, we can just go right ahead and count the empty spots. 1, 2, 3, 4 empty spots. So let us think about it. There are 10 parking spots. So that is represented as 10 parking spots out of the whole of 10. So it's represented like that. Then we know that if 6/10 took the spaces, it means that we're going to subtract. So 6/10 cars or 6/10 spots are taken by 6 cars. And if we counted 4 parking spaces remaining, we can go ahead and say that 4 out of the 10 parking spots are empty. And let's check to see if the algorithm or the shortcut work here. So here we can say that 10 minus 6 will give us a difference of 4, and the denominator remains the same. So yes, of course, it worked. Again, like magic. 4/10 is our fraction that represents the empty parking spots. Now, with the shortcut that we've been using, it is basically saying that you can subtract the numerators and write back the same denominator. So when you subtract the numerator, you'll put it the difference there in the numerator part, and you write back the same denominator. Like these, 7/9 minus 4/9 means that 7 minus 4 will give us, yes, 3, and we'll have the same denominator written back. So 3/9 will be our answer. And like this one again, 4/5 minus 3/5, we can simply subtract the numerators of 3 from 4, and that will give us 1. And then our fraction would be 1/5 for our answer. Here, the same with 13/13 minus 7/13. So we'll subtract the numerators from each other, or find the difference of the numerator, and given that the denominator is the same for both, we subtract 7 from 13 to give us a difference of 6, and we write back the same denominator. And this will give us a fraction of 6/13. Thank you for exploring with me today. Please like, share, and subscribe. See you next time.